All right, welcome everybody. This is our last session of Illini Aero Connections for the academic year. So thank you for joining us today. If you've been with us for the last three sessions, we thank you for joining for those as well. I think we have a really exciting session today all about ground and flight testing. As you know, these sessions are meant to enhance your curriculum and the classroom education that you get with topics that maybe you don't get to cover in the classroom themselves. So we have four great alumni on with us, and if you have joined us for any previous sessions, you already know Samantha McCue, who has helped develop this series, and I'm going to go ahead and turn things over to her now. Before I do that, though, we'll ask everyone to hold your questions until the end of the session, unless you need clarification on something that one of our speakers just said. Otherwise, if you can hold off to the end or put your question in the chat, and then we'll bring it up when it's appropriate. So, all right, Samantha, over to you.
All right, cool. Thanks, Courtney. So yeah, I am super excited for this session. This topic is near and dear to my heart because it is what I get to do on a daily basis as part of my career currently, and have been for almost since I graduated from Illinois. So we're going to talk a little bit about what it's really like in industry, in working in test, and how to get into one of those kinds of roles if it's something that you're interested in. And probably share some cool stories of test adventures that some of these alums have been on in their career. So to kick it off, we're going to do a quick little bio with each of our panelists, and we will start with you, Chris.
Hi, my name is Chris Lyon. I went to the University of Illinois as a graduate student and graduated in '98, I believe. From there, I went to Nebraska International, which is also in Urbana. Was there for 25 years doing flight simulation, and in support of the flight simulation, also flight testing. So validation data collection to validate that the simulations are correctly representing the real world. I'm currently at Anduril Industries. They do autonomous defense systems, and I'm part of the simulation group there. And that's it.
All right, Bill.
Hi, everybody. Bill Jaconetti. I am a flight test engineer at Boeing, and I've had the pleasure of being in flight test all of my 27 years that I've been out of University of Illinois. So I graduated in the fall of 1995 and hired into McDonnell Douglas at the time. And for the first 15 years, I did flight test on pretty much anything that goes fast and was made by McDonnell Douglas or Boeing. So started on the F-18E&F development program, and then did the X-32, which there is no F-32 out there in the world, so you guys might not know, but it was the Boeing's entrance into the Joint Strike Fighter competition. Then did various F-15 programs, and in 2010, left Boeing and went to the FAA and did flight tests for about 9 years there, and oversaw the development of the Cirrus jet, which is out there flying around today. And as well as a bunch of eVTOL aircraft. I was on the technical committee creating those cert bases. So came back to Boeing in 2019, and I'm now a senior flight test engineer and a technical fellow, associate technical fellow, developing a lot of training and procedures for the new people coming into flight test. But I still support advanced programs as well. That's it.
Thanks. And last but not least, Raymundo.
Hey guys, my name is Raymundo. I go by Ray, and I'm the youngest of the group. I have basically 2 years on me since I graduated from the University of Illinois. And there I got my undergrad in material science, actually, but then I got my master's degree in aerospace engineering, where I did mostly structures. Since I left Illinois, I've basically been doing tests. I started off as an internship at SpaceX, where I did structural testing. I got to organize a test for the orbital launch mount, the tower actually, down in Boca Chica. And then after that, I went a little bit more into the aerospace true roots and went into more of a fluid testing. And now I'm a Ursa major, which is over here in Colorado, and we make liquid rocket engines and we test them and blow a lot of dirt into the sky. So I don't have a very long and illustrious career yet, but you guys can also ask me any questions about, how I got here, and I'm happy to get to know you guys.
Awesome. Thank you. And then just a quick bio, I guess, on my test experience. I graduated from Illinois in 2012. Aerospace engineering undergrad, went to work for a small company that was a sub to Boeing, and then Boeing eventually, but all on the commercial crew program in the systems engineering integration and test group, where I did primarily ground test efforts and developmental test stuff. And then transitioned to working with 5D Systems, which is a KRATOS company. And I've been testing subscale aerial targets, as well as leading all of the flight efforts on the XQ-58A since it started flying. I was part of the original design team for that aircraft. So lots of different experience across the industry here on the call today. So I'm excited to get into some of this stuff. I think we'll kind of start at the beginning, Chris. When we look at how we all got into flight test and testing in general, I'm curious, how if you could talk a little about your transition from school environment to Frasca and how you ended up in test in the first place.
Yeah, so I never really intended to end up in test. It was more a necessity of the job that I was working at. So in the flight simulation world, you develop these flight models and you have to somehow validate them. So you need data to validate that. And typically what happens is you'll go to the aircraft manufacturer and you'll purchase that data. Unfortunately, the manufacturers are very proud of their data, so they charge you an arm and a leg. So Frasca, where I worked, was like, well, we're not going to pay that amount. Let's just do it ourselves. And so that's how I got kind of drafted in the flight test. And we sort of toyed around with it for a few years. And then once we started doing helicopters, and those OEMs are really proud of their data packages, the prices went way up. So that's when I got more serious about it and doing big programs on big aircraft. So yeah.
All right, Bill, how about you?
So in 1995, the aerospace industry was very different than it is right now. We're in kind of a new golden age where there's a lot going on. 95, it had really contracted a lot. So what got me in the door at McDonnell Douglas then was a combination of, I did aviation with aerospace engineering at U of I back when we had the flight school part of the university. And that's, even to this day, that's like an easy button for getting into flight test. If you have a pilot's license, there, for a lot of reasons we could talk about later, it really kind of makes you really well suited to that job. So yeah, that's how I initially got in. And, the reason I stayed was working with the end product the whole time. I didn't know that's where I was going to go or where I was going to stay. All I knew is that at my interview, as I was walking out the door, an F-15 took off out of St. Louis and, went straight up. And, it's like, wow, this is probably the place for me. But once I got to see that I got to work with the end product and really be a part of that every single day, it was really the way to, to keep doing what I love doing while, having a good, exciting job. So that was basically the move into it.
I gotta agree with Bill here on that 100%. Seeing the end product, being up and close to what is closest to the thing that's gonna fly, it makes it all worth it. All those hours and all the paperwork that you have to do anyway. Makes it way worth it. I got into testing kind of just by luck. I got an internship, but then I made the best of it and I did structural testing down at the Boca Chica site in SpaceX. And I really got to, I built a lot of tool sets and skill sets there for how to put a test together when you don't really have a lot to go off of. And I really like the adrenaline rush you get once it all comes together at the end, and you really get to see, whether it's GSE, I do ground testing, so it's not in the sky yet, but you really get to see the hardware get put through its paces, and you can really imagine and really see the product come to life. Yeah.
Awesome. Yeah, Bill, I think I'm gonna have to agree with you 100% on the pilot's license thing. I did the same aviation aerospace thing, and there's just some level of difference in operations when you can actually say that you've flown something and you understand how operations work. So I definitely recommend that if anyone's interested in doing that on the side or as a hobby, even though the school I think is now with Parkland, right? Or anywhere you can do it. If that interests you, I think that's a great add to your resume or to any future company that you work for. I think it's looked at as a great skill to have.
Yeah, it's certainly helped me as well. I'm a pilot, and I approach the flight testing from the engineering side, but also being a pilot, and because the way our organizations have flight tested, I'm on board for every flight. I actually get to act as the flight test pilot for a lot of the maneuvers. And so it opens up opportunities like that if you're actual pilot.
Yeah, that's really cool. So I think probably all of you were involved in something at the university while you were there, or maybe extracurriculars that got you involved in aviation, like we're talking about getting a pilot's license and doing, I think, testing in a university setting. At least for me, what I was involved in with like wind tunnel testing was very, very different than what I got to see or what I started doing when I went into industry. Could you guys maybe talk about differences, pros, cons to what you experienced and learned from a test perspective in school versus how it actually was when you entered the industry and started doing it there?
Yeah, I would say, well, so when I was a grad student at the University of Illinois, I worked in the wind tunnel, and so I would test low-speed airfoils, and those were long days and a lot of prep work, and then you would have to reduce the data, in the end. But in industry, the pace is much faster, and the pressure is higher. And if you make a mistake, it costs a lot more. And so you really have to have your ducks in a row and kind of be able to think on your feet and adapt, because everything's going to be moving so quickly. But the experience that you might get in school, it gets you a flavor of what's going to happen. So as you're going through a test program, there's going to be jargon that you hear and tasks, and hopefully it won't be the first time that you're hearing some of it, and it becomes a little bit easier to digest. But yeah, I would say from what I experienced in school to what I experienced in industry, it was the pace and the amount of responsibility and the ramifications if something goes wrong. It's all just kind of amped up way more. And for you guys that are going into space or going supersonic, I mean, it's probably even worse. All the stuff I work on doesn't go any faster than 200 knots. So if there's problems, it's not quite as bad, but yeah.
Yeah, so everything that Chris said resonates with me as well. I'll start by saying that U of I prepared me very well. Technically, it was absolutely no issue. The education that I got there, I was able to understand everything. But that being said, pretty much everything was different. Like you said, the stakes were high, the pace was super fast, and making the transition from learning about how to make an airplane to learning how to design a test to make sure that airplane that somebody else in your company made, does what it's supposed to do. It's really a mindset change. It's sometimes breaking things is what we want to do, depending on what the type of test is. So even though safety is baked into everything, so that's another thing that really at the undergrad level, we understood that safety was important, but in the industry, I mean, safety is really baked into everything we do, especially in flight tests. But safe doesn't mean you're not going to fly. So in the end, our job is to test it. So we really, making the decisions to how to build up in the right manner so that you're going from conservative to less conservative is the way to go. I will say one shout out. I see Professor Selig is on the line. He taught my senior design project. And we actually did get to do some flight testing in a simulator as part of that. That was the only flight testing I did when I came into McDonnell Douglas. And it at least gave me a little bit of an understanding of, what it was all about.
There we go. Yeah. I can only add to what they're saying. It's when you join industry, you trade your pencil for a wrench, and you really have to find out, or you come to a realization that all those really awesome tools that you spent a lot of time mastering, whether that's how to calculate loads, how to calculate, design something in CAD, how to, even organize a project, all of these things become just a tool set, but it's not the main goal of the project. The goal of most of our projects is, let's test this thing so we can sell it and we can fly it. And it's not a one-to-one relationship. So getting your hands dirty, that was, that has been a great experience for me. When I started my job here as doing test operations, I spent 3 months literally just outside every day, turning wrenches, installing rocket engines on the test stand, and getting jet fuel all over me. You learn real quick what clothes to wear and what shoes to wear, and what, being cold, I'm over that. I wear the warmest thing I can. So you really, your face hits the grindstone, and you start learning all the tips and tricks and the shortcuts that you really need to master in order to be really quick and good at your job as you become a more experienced engineer.
I'd like to hit on something that Bill said with regards to writing a test plan. When you're in school and you might have a research project or be part of a group that's doing research, you'll encounter test plans, and they're thorough enough to do your research that you're doing. In industry, what I've experienced is that if something goes wrong with your test plan, or it wasn't fully fleshed out, there are knock-on effects from that and ramifications that will follow you around for a long time afterwards. Whereas in school, there's sort of an end to things. You'll move on and start working. Whereas in a lot of the flight tests that I've done, me being a consumer of the data that I actually collect, I get aware that, like, oh, there's a result that this test plan has to generate, and if it doesn't generate that, I'm going to feel the pain in the future. Or if I'm providing that data package to a third party, they're going to come back to me in a year or two when they actually start using the package, and now I'm going to have to either explain why something was wrong or reprocess data. And so it kind of comes back to the responsibilities and the ramifications being bigger, and that drives you to make your test plans as thorough as you can. So yeah.
Yeah, I think one thing I would add to that is being really meaningful about the data you're collecting. I think in engineering world, we would all love to collect every piece of data we ever can, and we often try to. But I think a lot of times in industry, it's about what is the critical data and what are you going to do with that data once something's on the ground, right? We often collect a lot of data and then we go, well, now what, right? So having that plan for what are you going to do with the data, and is it actually going to answer the questions you want to go answer? I think in the world I live in a lot, we have a fun battle between our technicians, our maintenance technicians, and our engineers, right? And our engineers will engineer something until they're blue in the face, and our technicians will say, it was good enough 2 years ago. Why are you guys still talking about it? But it's finding that balance, right? Collecting enough data that you can make an educated decision, but not collecting so much that your organization or your team can't even begin to process it, and use it in a way that's meaningful. And I think that's constantly something we have to think about in industry, right? Because data costs money, both to collect and to store and to process and analyze and all that stuff. So I feel like in the university setting, it's kind of a free for all. It's collect all the data you can, and yay, you got data. But if you can't do anything with it, that's not super useful in the industry setting.
Yeah, actually, it's collect the least amount of data in industry that you can to validate the product or verify your requirements. It really is a mindset change, and whoever could figure out how to do it with the least amount of data, is going to have the lowest cost to test.
Yeah, and I think my graduate school in experience at U of I, and especially in like a senior design, that really prepared for me. Because number one thing I can take away from doing the master's program is, what is the question? Like, you can spend hours making simulations and looking at data, but unless you know what you're trying to answer, you will never find it.
Yeah, definitely. All good points. I want to transition to talk about a little bit of like real world examples of what you guys are working on. I know in some spaces that's probably going to be a little bit difficult, but I'm curious if you guys could each talk to maybe one of the most exciting tests or most impactful tests that you were able to be a part of, and basically, you know, what was the outcome? What was your role on that project?
Yeah, so for me, like every helicopter that I flight test has always been the most exciting and best program ever. Helicopters are just so interesting to me. So I get really worked up when I start flight testing one. One specifically would be the Sikorsky S-92. It's a very big helicopter, seats 19 people. It's 27,000 pounds, and so it's quite a monster to be crawling around on. And you know, as the lead flight test engineer on programs, I get to plan what the instrumentation is, plan what the maneuvers are. I install the instruments. I'm on board when we're flying it. I get to reduce all the data, and then I'm the poor unfortunate person that has to try to use the data that I collected afterwards. But yeah, it's so exciting to do that whole process, put all these instruments on, and then actually be there and see the data come back. Like I get totally worked up when I see charts, you know, lines on the screen. You hear a lot of people say, I don't want to see charts. Like, man, I just love looking at the little lines and do things, and like, oh, that's where we did this maneuver, and you know, that's where I almost got sick and everything. And that's like the exciting part, is being completely connected to the test article. You know, like you crawl around on it. You were saying, Ray, about being dirty and you trade in a pencil for a wrench. I come out with scars and bruises because I'm reaching into cavities to install things. And I would say like the really cool parts are, you know, being the mechanic, being the engineer, being the pilot, being completely connected to what I was flight testing is really that's the exciting part. And that's on every flight test that I do. It's, you know, every aircraft has quirks, and so it's fun to learn and crawl around on them and do the quirks. Yeah, from the small aircraft to the big ones, you know, they all have their fun aspects. So I would just say, don't be choosy about what you test, because it's all going to be fun. You know, if you really invest in it, it's going to be cool no matter what. So.
Yeah, following on with what Chris said, the most exciting project that I worked, and I mean, there's been a lot of them that have been really exciting. The helicopters I've worked on have all been kind of scary, so I applaud you still getting excited to do it. But at least being on board the helicopter is the X-32. The vertical takeoff and landing version, the X-32B. I was the lead test conductor, so I got to do the briefing, run the, you know, make all the test cards, run the mission from inside the control room. But this program in particular, kind of like Chris said, there was so much work that there were not enough people to do it. And when I look back at my career, that's the most exciting program, because there were so many tasks that needed to be done. You know, everybody was just stepping up. I mean, I was running thrust predictions, even though we had a propulsion team. There was nobody else to do it. The propulsion team was doing something else. But taking this airplane that was 30,000+ pounds and doing a short takeoff, flying out to supersonic, you know, open up a weapon bay, close it up, come back, and then vertical land. I mean, it's as close to magic as I've ever been involved with. So that was definitely the most exciting. That would be my advice for if you have choices about what test role you get into, try to get into something where you can, instead of just being pigeonholed into one little area, you can do a lot of stuff on that program, because I think that will that will be just by definition more interesting. It's going to be a lot of work, but it's going to be very interesting. And you will also get very dirty, as Chris and Ray both said.
Yeah, you gotta love the dirt. Yeah, and what I really liked about the test engineering role in general is you focus on breadth. Like, you might have to run calculations on whether is this going to get too hot, or am I going to have enough propellant? But at the same time, you're not doing the same thing every single day, and I like that variability. For me, my most exciting tests, I mean, there's hard to choose a couple, but I think for me, trying to simulate in-orbit restart tests on a liquid rocket engine. It also takes the full team of people. We run pretty scrappy. So, whether you're waiting for this 60-minute period to run out, you have to swap K bottles, swap propellants, whatever you need to do to get ready for the next burn, because our test facility isn't, as well prepared as we'd love it to. It's just a lot of excitement, a lot of coordination has to go on, and you really get to see a team come together. So those tests that have a lot of different constraints, whether it's temperature or duration, you need more propellants, you need specific entrance criterias. Those exciting tests, the ones that are really unique, those are the ones that I like a lot.
One thing that you said, Bill, that really hits home is, the amount of work. Like there are long hours when you're doing flight tests. Like, I don't think anybody on this seminar should be fooled into thinking that this is going to be an easy job if you sign up for it. I've never worked longer than I have when I'm in the field flight testing an aircraft. It's hard work, but like what you said, Ray, there's a team of people around you, and it's really quite fun, because when you're in that environment where there's long hours, it's almost like you're going into battle together, and you get a really cohesive team, and we're all eating dinner standing up in the hangar next to the aircraft because we can't afford the hours to go out to a restaurant. Somebody gets assigned to bring the food, and you really come out of it feeling completely exhausted, but also like, holy cow, we've got a great team and we accomplished a lot. Yeah.
Yeah, I agree. I think from an impactful situation, I think some of the things that stand out in my mind are unfortunately the bad days, right? The maybe losing an airplane or having something really bad happen. Unfortunately, I work in the space of unmanned systems, so people are not involved if you have a crash or something bad happen. But in the handful of times I've been a part of something like that, those were both terrible and probably the biggest days of learning and following weeks to those events, right? Where everything kind of stops for a minute and you realize what you're doing is actually, has consequences, and what it means to your organization and what it means to that kind of a product or platform. So those have been, very eye-opening experiences for me. From an exciting perspective, I think that the aircraft that I primarily work on now has probably been the highlight. When I was hired by my current company, it was, the XQ-58A was an idea on paper. And then I led the first flight test, less than 3 years later. So that was pretty insane to see that transformation in 3 years and be a part of the design, as well as seeing the realization to a product. And then, since then we've flown it, many times, and flown alongside F-35 and F-22 and all kinds of aircraft that people said, maybe some new aircraft that's unmanned shouldn't be flying that close to our exquisite fighter systems. But, we are, and we're kind of pushing that envelope, and it's a different kind of aircraft. It's something in this attritable space, which is a word that I think the government made up because I can tell you Microsoft Word definitely doesn't like it. But it's sort of this, what is the difference between, or what is the in between of, something that's it's not disposable, right? It's not a one-time use missile, but it's also not an exquisite system we're going to go service for the next 60 years. It's some kind of limited life. And how do we like measure those systems? What's good enough for those systems? What amount of money are we willing to put into those kinds of systems? And they're making a lot of interesting engineering decisions, because the government and the customers, the Air Force, the Navy, all these people, they're used to spending a lot of money and getting something they hope that's going to last for a very long time and that's very safe. And so we're kind of in this arena where they want to spend less money, but they're willing to take some additional risk. And so it's really fun as a in the flight test community, because you start to look at airplanes a little differently, in the sense that in a traditional aircraft where you have a man on board, if you crash that airplane, it would definitely be a mishap, right? You would go investigate that, you would figure out what happened. But in the case of these aircraft, maybe you don't, right? Maybe you say, hey, this aircraft costs less than the thing we're going to shoot from a fighter. Maybe we're willing to expend something like that. And so it brings up a whole host of new questions, and requires a lot of new policy writing and all kinds of stuff. That's been fun to be a part of, since we're kind of on the forefront of that as an aerospace community right now.
Some are designed to crash too, right? Crash into something or someone or whatever.
Exactly. Yeah. And maybe you don't plan for that to happen on the first mission, but maybe on its 10th mission, that's what its job is, right? So there's just all kinds of space where, I think it's cool as commercial, both, the aircraft and the spacecraft side has gone more commercial, and the industry has had this, big rise in opportunity. I think it's really cool to see how the government has tried to figure out how to play catch up and be a part of it, right? It's like, it's having to evolve because there's other stuff out there, which I think means it's a really cool time for students to be jumping in regardless of what part of the industry, because there's a lot of that happening that's transforming how things look right now.
Yeah. So what you said, Samantha, I've worked some weapons programs and some unpiloted systems. And, what I always talk about is there's flight test procedure and flight test discipline that is ingrained, that comes from the piloted aircraft world. And we want to use that to make sure that we don't screw up the stuff that we know how to not screw up, because sometimes that happens too. So if there's going to be a mishap with the vehicle, let's let it be because of the hard technical stuff it has to do, and not because of, we loaded the wrong software or the aircraft wasn't in the configuration we wanted. So that flight test discipline part of it is something we often bring from the piloted side to the unpiloted side.
Yeah, definitely. So I think, we've talked a little bit now about what we've each done in our careers, what's been exciting, what we've enjoyed. I guess curious what you guys would recommend to these students that are on the Zoom call with us, if they were interested in getting into either flight test or just test in general in the aerospace industry. What do you think they should be doing now while they're in school, and then as they enter industry to set themselves up for success?
Yeah, that's a hard question, because when you come out of school, you've learned all this stuff and you think, I'm gonna use all this stuff I just learned, and then you get into industry and you're like, I'm not using anything that I just learned. This is all completely different. Like, why did I even go to school? I think why you go to school is you learn how to learn, right? So when you're in your classes and you're going through projects, and it's important that you're cognizant of the details of the projects and the tasks, but you need to kind of ask yourself, how do you need to think to accomplish your goal? And if you get into the mind frame of big picture stuff, and not necessarily getting lost in the details, where you can stand back and you think, well, why did I just do that? What did it teach me? I think that's a really strong skill that you can get out of school that's going to transfer into industry. Now, more on the technical side, software skills. You can't overemphasize enough how much software is important. Whether it's doing actual data collection or doing data processing, or even the planning side. Like, if you're savvy with Excel and Microsoft Word, you can do tons of automation that can make your lives easier. So I know when I was going through undergrad, this was back in the Stone Ages, almost before computers, but I was really hesitant to get involved in the software, because I was an aero. I wanted to do fluids and airplane stuff, and what do I need software for? but there's no way I could function without software work. And so if you build up that toolbox, don't think of it like software, like, oh, I'm learning how to write in C++ or C#. Think of it as you're learning how to use a tool that in the future you can then put the work on some task that's going to make your life easier.
So holy cow, that was one of my key points, Chris, that I was going to say on the same thing. The proportion of calculus I did in undergrad versus coding is completely upside down now in industry. I do almost no calculus because we would never do it by hand anyway at a company, and I do lots and lots of coding. But like you said, I'm not in the software group. I don't write code for the aircraft to go do its flight controls. But if you can make a macro-enabled spreadsheet or a database or use Python and create a generalized linear model for something, those things are huge, and they will set you apart because a lot of people still don't know how to do that type of stuff. So that's huge. What I look for, and this is not just at my company, but when I was at the government side as well, somebody that has a love of airplanes. I mean, this is the type of job where it's amazing, but you have to have a love of airplanes to really keep that grind going. So we all talked about the long days when you're out in the field testing. Well, there's also like a long period of time where you have to test plan, and you might be years from seeing that thing fly, and you've got to be able to grind and stay focused and go meet with the SMEs and subject matter experts and design that test. So somebody loves airplanes. So go get a private pilot license, go get a Part 107 drone operator's license, participate in design, build, fly. The other thing that I always look for is somebody that can show on the resume or in the interview that they like to tinker with stuff. They like to find out how things work. Rebuilding cars, build your own computer, anything that is showing you just got that inquisitive nature, because that is what a tester really needs to have. It's like, why didn't that work? That was a little bit different than I thought it should have been. We better pull on that thread and figure it out. I love people that work in teams. So if you've got a demonstrated history of working in teams, even sports, I think really makes you suited to industry, because we don't do anything by ourselves. And then the professional societies, if you're in flight tests, there's a Society of Flight Test Engineers. If you're doing more ground test or system testing, there's ITEA, International Test and Evaluation Association. There's AIAA. Those are some things that can really prepare you well for the industry.
Yeah, Bill just gave it, like the pamphlet, great stuff there. I'd also recommend go out there and build something. It's really where theory, which you learn in class, and the real world meet that we test engineers excel at. You might be resource limited, and you really have to figure out, how am I going to build something to get this to work within X number of days or weeks. So yeah, I would really recommend, you join those RSOs where you can build something or be part of it. Obviously, you got to balance schoolwork, and that was a big challenge for me. So it's not as easy as just joining something and spending your whole day there. But just being out there and applying theory. And it is important, in industry, we do use Excel all the time. I am pretty freaked out by how much stuff happens on Excel because it's so easy to delete stuff. But it's very effective. What I would recommend too is all the time, we do use these tools, these software tools, to automate and make things go fast. But sometimes you have to take a step back and make sure that this approximation you're making is going to be acceptable, because there's sometimes that we're Bernoulli's might not apply, and you might fail a test because you thought it was fine. Usually it does work, but it's always good to use your engineering brain and your brain just to think things through while you get work done real quickly.
Yeah, I agree with all that. I think the other thing I would recommend from a looking at internship and full-time positions perspective is, a lot of organizations kind of house their systems engineering, integration, and test kind of in one silo, because they think of it as the systems engineering process from beginning to end. And so a lot of the people that either I've hired or I've worked with, ended up starting as what they called a systems engineer, saw what that environment was like, and then within their organization were able to navigate their way to testing, either directly because the system engineers were involved in testing, or they interfaced a lot with the integration and test group. So it was an easy transition. So I know a lot of times, as we've mentioned, like, you want to be the guy doing the flight control stuff, or you want to be doing the structure stuff that you learned in school. But I would say don't be scared of the systems engineering and test type roles if you're interested in that, because I do think that's the one way to get yourself in that part of an organization that's thinking about those kinds of things and get exposed to those kinds of things. All right. Well, yeah.
I would say don't be afraid of taking a calculated risk. Because at the end of my master's year, I had a job offer lined up for this company that wasn't aerospace. It was like data analysis, but it paid okay. And, I was about to accept it. It was close to family. Then I got an internship offer at the end of my career. But it would change my career, and it would let me be a test engineer in aerospace and do stuff in space, which is what I wanted, even if it did risk not getting a immediate full-time offer. So that's a risk I took. I was able to intern at SpaceX, and there, really it solidified my start and the basic skill sets that I use nowadays. So it's sometimes these companies offer these weird associateship internships. Just go take them with a grain of salt, but they are a way to change your career if you don't have the job opportunities that you are happy with.
One thing I think that's sort of worth pointing out, we're all in school, we want to be aeros, right? Whether it's fluids or aircraft design or whatnot, but don't be scared of just being an engineer, right? Like, you don't have to be an aero engineer. You can be an engineer that loves solving problems, and you've got a little bit of mechanical skills, some EE skills, some aero skills. That's what some of these test engineers are, just jacks of all trade. And if you do end up going down a route where you're not necessarily in aero and you're in systems engineering or test engineering, you're probably going to get exposed to a lot of things that will really build up your toolbox, so that as the future goes on and more job opportunities come your way, you're going to have all kinds of experience. I mean, that's one of the things that I think flight testing has really given me is exposure to thinking like a mechanical engineer, because I have to design a fixture to fit on the aircraft, and then thinking like a human factors engineer, because I have to design a fixture that the pilots can interact with, and how are they going to interact with it, and is it going to be an obstruction or whatnot. And so there's all these engineering disciplines that you can find yourself working in, that are just so much more than just being an aerospace engineer. So when you're in school, don't get stuck in your mind that you're gonna graduate and then you're gonna become an aero, right? Like, what you want to do is you want to graduate and become an effective engineer, and then you're gonna probably find that there's a bunch of different engineering out there that you love to do that you didn't ever think you were going to do. So just keep an open mind with regards to that.
Yeah, definitely agree. I do want to open it up for if anyone on the phone has questions. You're welcome to unmute and ask a particular panelist or everybody, or you could also type it into the chat. I've got a few in my back pocket in case we're going to be shy today and nobody has any, but I'll be quiet for a second. And if anyone has questions, feel free to shout them out.
Can I just unmute and ask a question if you don't mind? So I have two questions. One is from your point of view and from your experience at UFI, how important are the research experiences you had here for your future, like your later industrial experience?
For me, it was pretty vital. I had mentioned earlier that when I was in school, I wasn't that interested in doing software. And it was actually through doing my research with Professor Selig, that's where I got to actually understand like software is a tool. Because I needed that tool to be able to run the wind tunnel and process the data. And then, we even used software to write reports, whether that was LaTeX or what other kind of word processing automation that you might doing. And so, yeah.
Yeah, I guess unless your research was directly related to what you were, to what I was working on or testing, it's more about, like Chris said, it's about what you put into it and the processes and the discipline that you learn from doing detailed research and getting from a starting point to an end point that prepares you well for industry. But content wise, it would, you just have to hit that area that you wind up going into.
Yeah, I would say that, there are people with my same job role that don't have master's degrees or any sort of graduate school. But it does help you kind of just develop all these skill sets that you wouldn't get otherwise. Same with Chris, I did a lot of Python during my grad school, and that's super useful. Now everything is written in Python here, and it's like you need to know it in order to be able to create these tools that we use. I would say I do know people who turn their graduate degree into something that's directly applicable. Because, for example, I did a thesis and I could kind of shape my project. And if you can shape your project to be like the exact thing that you want to do once you graduate, you're going to be set up in golden. I know a guy who did a master's as well, but he literally did his master's in testing rocket engines. So when he graduated, he was the best guy at testing rocket engines. So yeah, yes, if you can take your project and mold it in any way that aligned with your passions, that's a sure ticket to be better off when you graduate.
I had one question come in on the chat that says, I was formerly at Boeing working in certification by analysis, and flight test was a huge factor, but I never got a chance to work into it. How has certification by analysis impacted the degree of testing or ways of testing? I guess I can comment a little bit on this from my perspective, although it's probably different than, what Chris and Bill would comment on based on the kinds of aircraft they work on. Where I'm at analysis, we're not having to do full certification of an aircraft because of the type of aircraft that it is, but analysis is being used heavily in lieu of expensive testing. And because budgets are continuing to be squeezed, we are continuing to do analysis and then very pointed ground and flight testing to go prove out specific things. But I guess open it up to Chris or Bill if you have comments specifically as it relates to the certification process and how that's looking.
So when I worked at Frasca, we were flight testing already certified aircraft. So the sort of flight test that we did wasn't envelope expansion or envelope development. We stayed within the operating envelope. In my current company, they're unmanned systems that are weapons, so they're not necessarily getting certified, but the sort of analysis that happens is there is a certain amount of flight testing that happens, and then we take that data and we do simulations that then we drive to match the data, and then those simulations are used by the rest of the company to expand the envelope of the test article or see if it can do a new mission. And so, I'm not sure if that's really certification by analysis, but it's an approach where you're not actually operating the vehicle for an extended time because it's expensive or dangerous or whatever, and you're trying to develop a analytical approach that works with data to say, yes, this vehicle is going to be able to accomplish a task. So I think as things get bigger and faster and more expensive and more dangerous, there's a general hesitancy to operate and fly because it's expensive and and dangerous. So yeah, there's always going to want to be a reliance on saving money and making things safe. So that means not flying.
Yeah, so this is a debate in industry that is just raging all the time. You know, the people that pay for the products want them as cheaply as possible, and flight testing costs money. You know, unfortunately, what we've seen is it's very, very difficult to simulate, especially edges of the envelope. Everything gets nonlinear, and it gets you know, just really hard to model. Now, in the industry, digital airplane is a huge thing. We're trying to simulate as much as we can, and we use that simulation to help prepare for flight testing. That's where I've seen the biggest benefit, is doing lots and lots of simulating and predicting, so that when we get to the actual flight test, it goes more smoothly. And then, you know, it's matching points on a line. And if you could extrapolate out or interpolate together, you can lower it. Now, what I will say is, having been on a team that was applying design of experiments methodology to flight test is really lean. Every time you run DOE on it, you find out you don't have enough points, which is very, very different than what the people who kind of said, hey, we should do design of experiments on this, thought they would get. You know, when we go test an F-15, and you know, we're not running, you know, thousands of points for flutter. You know, we're hitting the key areas and then making sure we're meeting predictions.
Yeah, I guess in my experience, you'll basically just hit some points to anchor analysis models, but you do try to save as much time as you can by not testing everything.
Other questions?
I had a question.
For it.
Earlier in the meeting, you guys said you were talking about how you needed to collect the least amount of data possible. How long did it take for you to know which data you actually needed to collect and which data was sort of kind of put to the side?
So from my aspect, trying to develop a simulation model, the validation data or the flight test data really is the foundation of those models. And you know, it took me several projects to realize that how much data I actually want. Usually when you go to an OEM and you get flight test data from them, their costs are really high, and they're giving you the bare minimum of data that they think they need to give you. So it's never enough. And so after working on a few projects that used OEM data, I was like, this is terrible. This isn't enough information to do anything. And so it grew the amount of data that I wanted. And then finally came the day where I said, I'm going to collect every single thing that I want. And I did it, and it just about killed me. And we didn't end up using, you know, half of it. And so in my experience, I kind of went from, you know, I wish I had all the data in the world, and wouldn't it be great if I had it, to where like, holy cow, that was terrible. And then you kind of back off and you realize, you know, I can do better than what I was getting when I first started on these projects, but I don't need to go all, you know, hog in and collect everything under the sun. And unfortunately, you know, that's the kind of stuff that's hard to teach. Is an engineer, you want it all, right? Like, you're super excited, you think you can do the greatest job ever, so you're going to want to collect everything. And it's not until you go through that process and you feel the pain that you realize, oh, I don't really need to collect everything. And then your expectations kind of tamper down a little bit.
Yeah, so I've got a couple, two parts of this answer. Number one, in some ways it's easier than you think, because if it's a certified airplane, FAA or whatever governing body is going to set requirements for how much data you need, what types of data that you need. Even on a lot of the military products, piloted aircraft, there's a MIL standard that covers, you must show these types of data in order to show that the system could be fielded. Where things get really hard, and we're going to see it more and more, physics are fairly repeatable. So things that you're doing for flight sciences type testing, aerostructural, you don't need to get a lot of repetition normally. If it does it, you normalize for, atmospheric effects, you should get the same answer every time. Some of these really complicated systems, electronic systems, don't follow those rules. So now you're starting to have to get some repeatability data and do some statistical analysis that is not what we would see in normal aerostructural flight tests. That's been a little bit harder. How many runs before you could say that this particular system is working properly? If it works on one, does that mean it's going to work on another? It's a tough question to answer.
Yeah, and I would agree that, when requirements are required, I guess, what you have to hit, but quite often there's a forcing function that is telling you go faster, do it cheaper, but still maintain the same quality and results. So there's always a forcing function, and especially like in my role, that's telling me to go faster. How can I be more efficient? How can I make sure that I'm not wasting people's time? And you just look at the problem long enough, and you start going through a lot of iterations. You start cutting out the fat.
Thank you.
Perfect. I think we have one last question in the chat we can address here in our last couple minutes. And it was kind of related to our previous question of, what do you wish you would have learned while in school that would have made your transition easier to your flight test career?
Yeah, I mean, this is going to sound kind of specific, I guess maybe to me, but double E stuff. Like, I wish I was way better at being a double E than I am. Sometimes, like, even the simplest things, I'm baffled by how the electricity got from one spot to the other, or why something just, sparked or zapped. Like, that's a skill that when I was going through school, I had mentioned about wanting to be an engineer instead of an aero engineer. I didn't want to be a double E engineer, so I kind of took the one double E course I was required to take and then moved on from it. And I really should have paid attention more in that class.
Yeah, so mine is, this might sound a little bit odd, but I wish that we had a flight test engineering course at U of I. I think it would be awesome. There are some universities that have them. You got some good alums out there that could help with content, but that's really the only thing. Like I said, technically U of I mean, there's nobody that's going to be able to talk beyond you when it comes to the technical education. I just wish that we had a little bit more of that flight test applicability. We've got an airplane, a aviation program over at Parkland that we could help utilize, and it would be really, really powerful. And there's other universities that are doing it. Embry-Riddle's doing it. We're hiring tons of people from Embry-Riddle, and I'd love to see more and more people coming from U of I.
Yeah, and I guess I'm kind of an edge case here because I started off doing more structural stuff, but I totally wish I took more fluid classes, I guess practical fluid dynamic classes, just so I had a really good fundamental understanding of all the different kinds of orifices and everything that I see now day to day. And I still scratch my head every day because I'm like, is this how it works? But having a background in material science, in my undergrad, I didn't get that bit. So definitely, if you took that class, you got a leg up on me, and I'll probably be seeing you soon.
Yeah, to a point you made, Bill, about you wish there was a flight test class, in lieu of being a graduate student and doing research, or an undergrad and being lucky enough to get involved in some of the research. A lot of the student projects are about as close as you're going to get, whether that's the design, build, fly, or I believe there's actually a group at the U of I that's building a real airplane. I don't know if that's EAA sponsored or something, but those are kind of your exposure to what would be as close to flight test as I think you might get right now.
Awesome. Well, I think we are about out of time for the panelists. Looks like there was another question. If you wouldn't mind typing your response to that one related to software programs you're using in the chat, that would help people see what you guys think on that one. I really appreciate your time today. This is exciting stuff. And if any of you are interested in continuing the conversation, please reach out to Courtney and she can put you in contact with these alums who I'm sure would be happy to talk with you more about, anything related to this testing topic that we've been talking today. And on that, Courtney, I will hand it back to you.
All right. Thank you to our panelists, Chris, Bill, Ray, and Samantha. Thank you so much for your expertise and your time today. It was incredibly interesting. I think all of our students and our faculty here would agree with that. So to everyone else, thank you for joining us for the last session of Illini Aero Connections. I've put a link in the chat if you wouldn't mind filling out a real quick form to let us know what you thought of today's session and also to give us ideas for topics next year that we could cover. Samantha and I are always looking for information on that. And we'd be glad for your input. So thank you all, and we hope to see you next time.
What's up, Chris?
Haven't seen you in a while, Jason.
Nope. Oh, at least you used my first name.
Yeah. And yes, I am that old.